Our second lesson on hypothesis testing, where what we'll do is we'll see what information the p-values are giving us. So we're going to return to the same examples we saw in the first lesson. Here was our first example that some study concluded that rugby players are more likely to sustain broken noses than soccer players, p less than 0.03. So let's recall that we're looking at two groups, rugby players and soccer players, and we're looking for a difference between those groups in the number of broken noses. And so what we do for our null hypothesis again is we conclude that there is no difference between the two groups. And then our alternative hypothesis was perhaps that the rugby players are in fact more likely to sustain broken noses. So here we see the null hypothesis and the alternative hypothesis. Now, the p-value, well, what we need to do is understand that any conclusion reached in statistics has some amount of doubt attached to it. So we can't conclude for absolute certain that rugby players are more likely to sustain broken noses than soccer players. I should say any conclusion reached by statistical inference, where we've sampled and then tried to extrapolate those results to a general population. So it's very the fact that the researcher concluded that rugby players are more likely to sustain broken noses than soccer players indicates that it's quite likely true, but there's the possibility in fact that it's not true. So what we'd like to do is quantify that in terms of the probability that that statement really is true or that it's not true. And we do that with the p-value. Now I'm going to give you the technical definition of the p-value first, which is a little bit challenging to understand, and then we'll interpret it loosely in a less formal way. So what the p-value really tells us is it indicates the maximum probability of seeing the results, in other words, getting the kind of data that the researchers got, if in fact the null hypothesis was true. So in this case, what this is saying is that our p-value, you can barely see it up here, it's p is less than 0.03 or p is less than 3%. And so the p-value gives the maximum probability. We have a maximum probability of 3% that we could in fact get data that indicates that rugby players are more likely to sustain broken noses than soccer players, when in fact that wouldn't really be true, when in fact the null hypothesis was true. Now again, that's a fairly technical and somewhat difficult thing to understand, so we're going to go to a less formal interpretation here in just a moment. But let me finish with the fact that so that 3% gives us the likelihood of seeing the kind of data we did if in fact rugby players are no more likely to sustain broken noses. So then that means either our data came out with very unusual results, or maybe our null hypothesis is not true, in which case we would then reject it and accept the null, or we would reject the null hypothesis. We'll use that language, which means that we then assume the alternative is true. So again, let's go to our less formal interpretation. So let me just show you again the same conclusion, same null and alternative hypothesis, and now we'll look at a slightly different interpretation of the p-value. So another way of looking at the p-value in some sense is that the p-value indicates the maximum probability that the null hypothesis is true. So in this case, what we would say is that we can see I've said exactly that here. So in this case, there's a chance that rugby players are no more likely to sustain broken noses than soccer players, which is the null hypothesis, but the probability of that is less than 3%. So the equivalent statement would be, of course, that there's at least a 97% chance, a 97% or more chance that rugby players are more likely to sustain broken noses than soccer players. Okay, moving on to our second example from the previous lesson. In this case, the conclusion was that a relationship was found between genders and majors of students in Math 243. Here our p-value is less than 0.02 or less than 0.2%. Just a reminder, here's the null and alternative hypothesis. And so we interpret the p-value that as saying that there's a less than a 2% chance that the null hypothesis is true. So there's at least a 98% chance that there is a relationship between genders and majors of students in Math 243. And I've written both of those statements here. Because the p-value is less than 0.02, there's less than a 2% chance that there's no relationship between genders and majors of students in Math 243. That is, there's less than a 2% chance that the null hypothesis is true, so there's at least a 98% chance that the alternative hypothesis is true. Okay, so that's what this paragraph here indicates to us. Okay, so when we conclude with a positive affirmation of a finding or a relationship like this one, in other words, an affirmation of the alternative hypothesis, the probability that the finding holds is at least 1 minus the p-value, or 1 minus 0.02, which is 0.98 or 98%. And we'll conclude by, again, looking at our last example from the previous lesson. And you may or may not recall that this example, the conclusion was that there was no significant difference found between the average Math 243 scores of psychology majors and communication majors. The p is 0.35. Let's try interpreting that before we look at our hypotheses, or let's think about our hypotheses. The null hypothesis would be that there is no difference between average Math 243 scores of psychology majors and communications majors. And this is the maximum probability that there is no difference. So there's a probability of 35% or less that there is no difference. There'd be the inverse or the complementary probability of 65% chance that there is in fact a difference. So we indicate those two things here. The probability that there is no difference is less than 35%, and the probability that there is a difference is at least 65%. Now you might ask, well, if there's a 65% chance or more that there is a difference in the scores, why didn't the researchers conclude that? Well, because a probability of 65% is not all that high. I mean, ask yourself whether you would bet, say, $1,000 in some situation where you had only a 65% chance of winning. I'd say many of us would be likely to not bet in that case. So even though 65% is over 50%, it's not a terribly high probability. So when we don't have a probability that's very high, and we'll talk later about what people consider to be a high enough probability, then in this case we're not going to reject our null hypothesis. There's not enough evidence. This is not a high enough probability for us to not think to think that there actually is in fact a difference. So we're just going to presume innocence, or conclude innocence like we would in a court of law. So that concludes our second lesson here on hypothesis testing over what a p-value tells us.